First of all, what do you mean by twist? So different schools of thoughts, they have defined twist in different ways. Number one, according to Steele, yarn twist is defined as the spiral deposition of the component of a twist is the measure of the spiral terms given to a yarn in order to hold the constituent fibers or threads together. It means the first view of Steele is indicating that the spiral deposition, that's whenever we are applying the torsional force. Are you getting? I think the twist terminology is not new for you people because you are usually know it twist. But in different way, what will be the definition? You have to know these things. So whenever we are giving the spiral terms, means we are applying the torsional force. At that time, what will happen? The fiber assembly or the filament, it will turn, and ultimately due to turning, the spiral deposition of fiber or filament, and ultimately it is producing a continuous strand of material, that is yarn, maybe sponge or filament. And another definition of mortar, when a strand is twisted, the component of fibers tend to take on a spiral formation. The geometry perfection of which depends on their original formation. This is the view of mortar. So, according to Wool Research Organization, the twist definition is twist may be defined as the rotation about the yarn axis of a line drawn on the yarn, which was originally before twisting parallel to the yarn axis. This is the view of Wool Research Organization of HERA. So different schools of thought, different organizations, they have defined the twist definition. But one thing is that in a word I can say, due to torsional forces, what will happen? That your yarn or fiber will bend or spirally move. Due to the spiral movement, what will happen? The fiber to fiber friction will increase, and ultimately they are remaining within a system and ultimately producing yarn. In a word, we call as twist. And another thing is that in our laboratory, we measure the twist is number of spiral turns per unit length. Number of spiral turns per unit length. This is turns per inch, turns per centimeter. I think turns per meter in this way. You can calculate this. So next one, type of twist is very important. Two types. One is real twist, or we call as a true twist, and that is your false twist. What is true twist? True twist means one point. The 2 points of the 1 point should be gripped. Another point, you will apply the torsional force. What will happen? The twist will propagate from starting point to the tip or the holding point. In case of ring spinning system, what is happening? The ring spinning, the point of contact between the ring and the traveler. Yarn, traveler and ring is the point of contact. This is the point of origin of twist, and twist is propagating from this point towards the front roller knee. In ring spinning system, are you recalling these things? From traveler and yarn contact point towards the front roller knee. The twist is propagating. So this is your true twist. But in false twist, what is happening? When we insert yarn. Both ends of the yarn are clamped usually by rollers, and twist is inserted with a false twister between the clamping point as indicated in figure B. You see the figure, true twist and false twist or real twist. You see, this is this point. Here we are applying the torsional force or twist. One point is gripped, another point is open. So here from this point I am applying twist. So this is to be called as real twist or true twist. But in false twist, you see, this is your material or yarn, I can say. So two gripping points. Right at the midpoint, we have applied the twist. What will happen? So we are holding both the side of the yarn and we are applying the twist. Not yarn, maybe a fiber strand, maybe fiber strand. Not yarn, I can say fiber strand or a yarn, whatever it may be. So both the side we are gripped. We have gripped it. I think you understand. At the midpoint, we are applying what? We are applying twist. So due to the application of the twist of the torsional force, what will happen? This direction, in upper direction, Z twist is propagating here from the picture, and lower direction, it is your S twist is propagating. So opposite direction of the twist is propagating from the point of application of the twisting object. Are you getting me? So here the twisting object is there. This object is giving twist at the mid. What will happen? From top side or one side, one direction of twist, another side, opposite direction of the twist is propagated. Clear? If I take out this twisting object, if I remove it, what will be the resultant twist within the material? 0. Because suppose in this direction x, in this direction minus x minus x, resultant how much? 0. So 0. That's why we call as false twist. We are applying the twist, but due to the two directional opposite movement of your twist, to a direction of the twist causes ultimately resultant twist value is 0. That's why this twist is called as 0 twist. But do you know the application of the 0 twist? 0 twist means false twist. Application of false twist. Already you had gone through in spinning, in roving frame. Simplex. Roving frame means simplex. Where
false twister
at the plier top, please remember me, at the plier top having groups. Am I right? The rope is coming through the plier top. So at the plier top we call as false twister. But why should I apply? What is the necessity of the false twist here? Because when the roving is coming out from the drafting zone towards the when the roving frame is towards the bobbin. So if we not apply this twist, ultimately the breakage, disengage or breakage of the roving taking place. And our target is to apply the twist to hold the fiber strand. Am I right? But practically, how much twist will be there within the roving? Some twist. So mathematics is saying the twist level within the roving must be 0. Yes or no? From normal mathematics, what it is predicting? It is predicting that amount of S twist, amount of Z twist is same. It means 0 twist. Ultimately, twist value is 0. But the textile material is very flexible enough. So what will happen? Mathematics say 0, but some residual twist will be there within the fiber strand that is helping to hold the the fiber strand, and ultimately it is helping to make the bobbin. Got my point? And this particular twist, whatever the minimum amount of twist, residual twist is remaining within the roving, that twist we remove during the ring spinning. That is one brake draft. You are recalling the brake draft. The value lies in between 1 to 2. So the brake draft region. So we are removing the residual twist which is remaining within the roving during formation. Okay. So whatever it may be. So here I think you are understanding the meaning of true twist and false twist. So this part is from my part. So next thing is the expression of twist. How to express the twist. I think this is not a new topic for you. You know these things. There are 3 ways we can express: twist per inch, twist per meter, twist per centimeter. So no need to explain these things. Factor affecting twist. Which factor is affecting maybe twist? The twist introduced in the yarn during spinning depends upon a number of factors, such as the count of yarn to be spun. Yarn count is an influencing factor. The quality of cotton. What type of cotton you are using? Means micrometer value, cotton, the rigidity of the cotton, that thing, that parameter. The use to which the yarn is put is the yarn meant to be used as warp yarn or weft yarn, knitted yarn, or any other type of yarn. So ultimately, whatever yarn you are producing, it is depending upon the end use requirement. Whether they are using this yarn for weft purpose, whether they are using the yarn for the warp purpose, or you are using for hosier yarn for knitted purpose. So it depends. Accordingly, you can change it. The fineness of the fiber during spun. Fiber fineness. Next, the softness of the fabric into which the yarn to be converted. Softness, twist factor. Higher the twist, higher lower the softness. Am I right? Higher the twist level, yarn will be hard. Lower the twist, yarn will be soft. In practice, yarn twist is described using the 3 main parameters: twist direction, twist factor or twist multiplier, and twist level, turns per unit frame. So 3 important. Please listen. Twist direction, whether it is S twist or it is Z twist. Another is your twist factor or twist multiplier. So this terminology, different schools of thoughts are expressing. Some people are calling as twist factor. Some people are addressing twist multiplier. Some people are telling in case of direct system, people are addressing this. Some people are calling in indirect system, we are addressing this. But I want to say, this is my point of view, twist factor and twist multiplier are on the different word. But people are expressing in different situation or different conditions. Then twist level, amount of twist remaining. Then I think what is S twist, what is S twist. So in a one I can give the answer also. S twist means anti-clockwise direction. When the twist is remaining in anti-clockwise direction. And Z twist is clockwise direction. So it's very simple one. Then twist factor or twist multiplier. Here you see in case of direct system, Tm equal to TPC into root x, or in indirect system, twist multiplier Tm equal to TPI by root count. Root count is in new in this system. Twist factor or twist multiplier. Its importance. Number 1. High twist multiplier are used to increase the yarn tenacity and yarn elongation. Twist multiplier অধিকার হলে পড়ব। Next, to produce clean yarns. To produce clean, see. To produce clean yarns with low gases. If the twist level is more, what will happen? The hairiness of the fiber. Hairiness means the protruding fiber. Our protruding fiber means the fiber which is away from the main stream of the yarn, that is protruding. Then low hairiness to improve the spinning stability. Spinning performance will be the perfect one. To obtain a clean cut fabric appearance. It is well known to you if the hairiness level of the yarn is less. So what will happen? Fabric surface is clean. So you please remember the singeing. Singeing is a process by which you are removing the protruding fiber. So I think you are recalling this thing. So that's why we are doing the singeing step. But here if the twist level is good, twist multiplier is high. So what will happen? Your hairiness is less. So surface will be more or less clean. To improve the shifting resistance of the yarn. These things I will discuss later. The lower twist multiplier, if the twist multiplier level is less, what will happen? To achieve a soft hand in the final hand. So what I told, if the twist multiplier is less, this means less amount of twist is remaining within the yarn. So less twist means material is soft. To produce bulky and more hairy yarns, what will happen? Twist level is less, so what will happen? Yarn will be more bulkier, thickness will be yarn will be more, and hairiness tendency simultaneously more. To reduce a yarn's tendency to snarl, here, have you heard the name snarl? So if you are applying more twist, if the twist is remaining, more quantity of twist is remaining within the yarn, if you just one point you grip it and relax the yarn, what will happen? The yarn will be entering or yarn will wrap over each other, and this is to be ultimately this technique called C, that is snarling form. So due to over twist. Increase output with the same proto speed, whatever it may be, is not the student and not quite discussing. So these are all twist factor out is twist level. Twist level expressed in the number of turns per unit length. Twist level of twist, but turns per unit length. Twist level. I think this is not new to you. Function of twist in a yarn structure. So here the main topic of discussion. There are two varieties of in our normal life. We mainly handle two types of yarns. One is filament yarn and is spun yarn. So first of all, what is spun yarn? Anyone can give the answer? What is spun yarn? Spun yarn is such type of yarn where it consists of discontinuous fiber strand. Am I right? Spun yarn consisting of discontinuous fiber strand. It means the staple fiber strand. This is not a continuous one, but filament yarn is such type of yarn we are getting a continuous yarn or continuous fiber filaments. I can say that is the basic difference. Your spun yarn and filament yarn. Here, in case of this graphical representation, it can express properly. Here I have represented your twist strain curve. Twist strain curve of filament yarn as well as spun yarn. You see, along the x-axis I have represented twist factor or twist multiplier. Then in y-axis, this is your yarn strength. This A curve for filament yarn and your B curve for span. Clear? So let us start discuss why should I apply twist for span yarn. Span yarn means it consists of discontinuous fiber strand. Are you getting me? Discontinuous fiber strand. Whenever you are applying twist, true twist means you are applying true twist to a discontinuous fiber strand. What will happen? Due to twist, fiber to fiber cohesive force develops, because you are gripping one point and you are applying the twist. Due to the spiral torque, due to application of the torque or twist, what will happen? The outer fiber, a fiber strand consists of number of fibers and number of layers also there. Am I right? Number of layers, outermost layer, then next layer, then next layer, then inner layer. So whenever they are applying the torsional force, what will happen? The fiber strand which are remaining at the outermost layer, it will move spirally. Are you understanding me? So parallel strand, suppose you think a parallel strand of fibers, means staple fibers are there. I am applying true twist. With one point, I am applying the twist. What will happen? Due to the application of the twist, the surface fibers within the fiber strand, it will move initially spirally. Due to spiral movement of the fiber strand at the outermost layer, it will increase the compressive force. It will increase the compressive force to the subsequent layers, inner layers. Force applied कर दिया, क्या हुआ? Compressive force it will apply. Due to increase of the compressive force, what will happen? Fiber to fiber friction force will increase, because fibers are coming very closer to each other. Suppose number of fibers are there, you are twisting. What will happen? They are coming closer to each other due to spiral movement of the outermost layer fibers. Outermost layer fibers, as it is spirally moving, what will happen? It will apply the compressive force. Compressive force. Due to the application of the inner compressive force, fiber to fiber friction will increase. Increase of the fiber to fiber friction causes increase of the load bearing capacity of the fiber strand. It means increase of the strength. That thing we are observing. See, when we are applying the twist, when the twist level is increasing, the strength of the span yarn is increasing. Are you understanding? And up to reaching a particular point, this is optimum point, what will happen? This is a maximum strain, a twist factor at which we are achieving maximum strain. This twist factor is called optimum twist factor. Optimum twist factor or twist multiplier. So the what is normally in an examination, this type of questions people are asking. So what do you mean by optimum twist factor or twist multiplier? The twist multiplier, the value of twist multiplier at which maximum tensile strength is achieved. The twist factor where we are achieving maximum tensile strength. So this curve also showing that. So gradually increase of twist causes increase of strength, and ultimately a point, just reaching at a point where the maximum strength already we have achieved. This is the maximum limit. So at that time you have to find out what will be your twist factor. That is your optimum twist factor. After reaching this optimum twist, optimum strength, then you are observing gradually the strength of the material or yarn is reducing. Why this declination? Why it is reducing? Because you are applying the twist, application of the twist spirally, what will happen? The yarn, the fibers will be spirally bent, and ultimately a situation will come, the surface fiber rupture taking place. Number one, breakage, rupture or breakage, surface fiber breakage taking place. Surface after optimum level. If surface fiber will break, what will happen? The compressive force will decrease, yes or no? Decrease of the breakage or rupture of surface fiber causes decrease of compressive force. Decrease of compressive force means decrease of fiber to fiber friction, and ultimately you are observing the declining nature, loss extent. That's why always we try to keep up to optimum use. Clear? Then another reason of declining after optimum level, this effect is called obliquity effect. This effect is called obliquity effect. You see, when the, please listen one thing. In tensile testing, what we do, we apply the load along the principal axis of the material. यान में स्ट्रेंथ मौका हुए हमें कौन करूं प्रिंसिपल एक्सिस रे यान को लोड करावे. सपोज it is your yarn, we apply the load here or here, whatever it may. As this is the central axis, inside central axis, so we are applying the load along the central axis of the yarn. So this is, I am assuming it is T force, T tension force. Apply T force to break it. If the fibers are parallel to each other, in a yarn, so all the fiber will share the load. Am I not right? I am applying the load towards gravity. For example, if the fibers within the fiber strand, it is parallel to each other. So what will happen? It will share the load. But in case of span, if the fibers are parallel to each other, what will happen? The strength will be very, very less. In span yarn, what will discontinue fiber strands of yarn? So if I apply the load, if the fibers are parallel to each other, if I apply the load, automatically very less amount of load is required to break it. So it is not our need. We are applying the twist. The twist is holding the fiber strand. That's why we are getting the strength. So as the fiber, due to twist, fibers are spirally bent. Got my point? As is spirally bent, what will happen? The number of load bearing fibers, if it is more spirally bent, what will happen? The T cos theta component will come into play. As it is bending or spirally, it is fiber strands are spirally deposited. What will happen? If I am applying the load, so fiber, how much load the fibers are sharing? Not T amount, because they are not parallel to each other. So one component of the load, that is T cos theta amount of load, will share it. So after this region, majority of the fiber, if I am increasing the twist level, what will happen after optimum twist factor? So what will happen? The fibers are more fibers are spirally placed each other. More spiral means T cos theta component will coming into place. So amount of load bearing capacity of the yarn will be reduced. Got my point? That's why this effect, this spiral effect is called obliquity effect. This spiral effect is called obliquity effect. So after optimum twist factor level, reduction of the tensile strength of yarn is due to your rupture of surface fiber. Number 2, due to the obliquity. Clear? In case of filament yarn, why should I apply twist and what is the effect of twist? You see, in case of filament yarn, when I am applying the twist, some extent, very little amount, increase of the strain is noticed. Alpha strain body. Then strain, the tensile strength of the material is declining one, is reducing. It reduces, yes or no? Tensile strength is reducing, yes or no? Yes. What is the result here? So initially it is increasing very little quantity, then it is decreasing. Filament yarn means it is parallel strand of fibers, am I not parallel thread with continuous fibers? The parallel fibers, continuous fibers, that ultimately they are producing the filament yarn. So in case of filament yarn, if I am increasing slight twist, what will happen? Due to the clustering effect of the filament, what will happen? Clustering effect. So one thing is that all filament having same strength? No. Some filament having some weak point, or something less. Some filament having higher strength. So what will happen? Whenever I am making a filament yarn and slight twist I am giving, what will happen? The filaments are coming very closer to each other. So due to as they are coming very closer and little amount of twist will be there, due to the clustering effect, the load bearing capacity of the filament yarn will be increased. Clear? After that, whenever after optimum level, when I am increasing the twist level, what will happen? Due to oblique effect and due to your surface filament breakage, the strength of the filament yarn will decrease. This is the result. In examination, they are asking the question that graphically explain the twist strain relationship in case of span yarn, in case of filament. I think I am clear.